Hello, everybody. So we're in module 8 now, coming near the end. I'll let him in. And then get started. Okay. So coming on the end very, very quickly. Everything ends on Sunday at 11:59 p.m. So I never extend beyond that final deadline for the course. That there's been some issues over the years where people have had to go through. It ended up being big deals. I once spent many, many hours helping somebody dig through VA paperwork to find a loophole because I would not budge on that final deadline for the course. He had a good case. It was just there was a mountain of VA paperwork in order to find it. So I did sit down and help him dig through the paperwork and find the clause he needed in order to not owe the government $6,000. But I still wasn't budgeting on the final deadline. So that March 12th, 11:59 p.m. was set several years ago as the end of our course. So we know the deadline's there. Just please make sure you get everything to me by then. I wake up early in the mornings, and on Monday, the day after the semester ends, I will wake up and finish up any grading that hasn't been done yet. And since I wake up early, I'm usually done with that by 7 or 7:30, way before most computer people wake up. So just please make sure you get everything to me by that final deadline. That's fine, Tiff. Saw that message in the chat room. More people coming in late. Okay. So as we approach the end, I like to front load courses so that when we get near the end, there's time to work on projects. Right, we have a big project here, but most of y'all have more than just this class, right? So there's probably plenty of stuff you have to work on as we get near the end. We've really barely scratched the surface of Python. Hopefully you've developed, or you're feeling like you've starting to develop a good solid foundation in Python. There's a lot of stuff we can still see, lots of odds and ends, things that will be useful. And I have a list of things that I found to be useful over the years. And I guess for this week, I just want to fill up some time with those things that I believe will be useful, but they weren't actually included in our the actual structure for our class. Ones I just realized a few minutes ago we never looked at. We never looked at anything from the OS module, and there's some important stuff in there. So we'll look at that. And I wrote Pi serial on the list for tonight, but I forgot to bring. I forgot to make a device to do that. I have a bunch of components in my office. I would need at least 15 minutes to put some buttons on the microcontroller and write some code for that. Well, you all had that microcontroller lab last week. Those connect to a computer through the USB port, or perhaps a network interface card and connect to another computer through the Wi-Fi. Either way, in general, if we're going between computers, USB is a great example because the S stands, right? Everybody knows what that stands for, right? Universal Serial Bus Connection. In particular, serial. It's serial communication, which means we have one wire that we transfer our bits down. Serial, so we have one wire that we transfer all our data down, 1 0 0 1 0 1 1, something like that. We write it like this usually, but it's kind of like your light switch. It's either the whole wire is on or the whole wire is off. But that would be awful to write. Versus parallel communication. Not trash can close by. Throw that away later. parallel communication, where we have a bunch of different wires. And we send each bit down its own wire. This works a lot better internal to a machine, like built into that printed circuit board or SMT board. But built in inside the machine, it's a lot easier to have 8 or 64 wires running together. If we're plugging up to another machine, it's kind of difficult to plug up 64 wires. So we usually do serial between machines. And an important library, I forgot to make a device, so we'll probably look at this Wednesday. Figured I'd go ahead and talk about it because it was the first thing I put on the list. Is how, if we're getting our data directly from another machine, like down the USB port, how do we deal with that with a Python script? And there's a library ready to be used. It's PySerial. So maybe let's just look at that in case I get busy that day as well and don't get a machine made. I've got several Arduinos over in my office, so it won't take long to build them. But that is a very useful library. Just install it. And they don't have any examples here. I use it a lot for testing things, because before making the HID report, a plug and play device, which is sort of a mix of the complicated way of writing C++ code mixed with some assembly language, mixed with some machine language, doing bit shift and port manipulation. That's really, really complicated and hard to debug. So usually I'll create something with the Arduino library that's easy to use for microcontrollers, designed to be easy to control, to program a microcontroller, and then send that down the serial port and pick it up with the PySerial library, which is written in Python. We all know how Python's easy to use, right? Everything about Python is to be easy to use, and then do all the debugging on the logic that way. So I don't have to debug the logic in the really complicated way where sometimes I'm just doing port manipulation and the coding is saying things like, okay, in register 0x8b, put a 1 in the third spot. It's kind of hard to debug the code, like much easier to debug the code in Python, even though that requires writing the same program twice. Get the logic together somewhere easy. That's where I use it the most. But Wi-Fi connections or internet connections, they are serial communication. Lots of places, basically anytime we connect two machines, it's almost always serial communication. So if it's coming from another machine, we might want to do something with it in our script. Just in case I get busy and don't pull that up, I'm sure I have an example here somewhere I can point at. Actually, throw something on Drive, I can point at quicker. With my stuff and programming things, should be a bunch of Arduino stuff from previous computer. Accelerometer. I don't see the one I was actually looking for though. I thought it was right here. Maybe it's somewhere else in.
Walk a dog.
That was my first game entirely from scratch.
That was so cool.
All
So
graphics.
you have to make the legs, you have to make the legs move simultaneously.
Try to make it look right. It's still very basic.
Cool.
And that was my first engine entirely from scratch. So not just game. I was building the engine and the game and everything. Oh, not really. Because I guess the stuff back when I was a kid, I had to do it from scratch every time then. So with modern software, so like 2013, as opposed to 1992. So that's why this the second generation of first engine I made. Or did I not save any of those things? Accelerometer position test. Maybe it is on GitHub. Let me check my repositories. I have to go in this way, don't I? It's probably not on there. Probably not. Huh. Can't remember where this might be stored at, so I will just look for one later. Oh wait, serial mouse. There it is. It wasn't the place I thought it was. It just didn't have the name I thought it was. Okay, so this is what it looks like in Python. So this eventually became this was an early draft of the paintbrush that waves around in midair to control the graphic software. This was an early step of that, but the one for that is much messier to look at. The final version. But we say what port we're going on. So if I was to say open device manager here. And so there's the USB stuff, but there's also our list of ports somewhere. I have something plugged up. There should be something on ports. New firmware, gateways, use process. Well, maybe somewhere in devices, I guess when you have one plugged up, there'll be a list of ports. And if your computer will remember that particular device, so every time you plug it up, it uses the same number of port. So you just set up that port number and the baud rate, which for some reason it always gets spelled in capital letters, so people think it's an acronym. It is somebody's name. This is the traditional metric units for oscillations. Like you're probably used to seeing a wave or something, and we have the like that. This is the whole wave passing. So we have the frequency, which is a much more common one. But in the case of this wave, there are two oscillations in that frequency, right? The up and the down. So baud are the metric units of how we measure those oscillations. Because I wrote it like this, like it's going down one wire, but we really take a wave and we kind of hide a bunch of data inside of a wave. There's some maximization things going on that make a big difference. So different numbers, but that's we need what port is it coming down and how many oscillations, what's the speed of the oscillations we should be measuring. Then we just set our thing up. It all comes in as binary strings. Hopefully I'll be able to get something together really quick before Wednesday, and I'll put something with a couple buttons and a knob or something so we can look at it. And then it's just reading that in. It reads in a binary string. So like here, it writes this command, XBrush. So it writes that, sends it down the serial line. And then on the other end, the other machine recognizes that word and sends back, in this case, the accelerometer position and speed based off the starting position. Okay, gyroscope accelerometer, combination of gyroscope, so it knows where it started at and its orientation, and the accelerometer to show how it's currently moving. We're getting all that data, converted, read in what comes back, and convert it to an integer, And this is an early draft, so all I was doing was printing it out here. The big thing is this, we import the pie cereal or cereal library. There's another thing called cereal, but if we import pie cereal, it will take precedence over the default cereal library, which does something else. So with that, we just create this object. What port is the data coming down? Which you get that number from, from device manager. And then what is the speed that it's coming down? And you would set that at the, you would set that in your controls on the other end before it sends it. So a really useful one, especially with the prevalence of IoT taking off. We might need that. I decided to go ahead and point at stuff because the next one I kind of have to point at. I thought it would be in there. Actually, I didn't think about it until recently and didn't get around to checking until this morning, but we couldn't do it in our AWS accounts. But if I go to AWS Academy, another very important one you will want to look into when you get a chance for our modern world, AWS calls Lambda functions. Azure and Google Cloud both call them just cloud functions. I think Linode might also call them Lambda functions, but there's several different names depending on the cloud provider, but they're all basically the same thing. So instead of setting up a server and loading all our software on the server and launching that out, what we saw with APIs returning data, we can do that with a single function. So we would just go write a Python function on the cloud and somebody enters the right URL and it runs that function and gives them that one result back. It is incredibly useful. You can link to that in like multiple web pages or just have a button that goes directly to it itself, shows the results. But basically think of it as one single function that you would run from the address bar in your browser. So anything that can access the internet can run that function and call that function and get the results. Instead of the traditional import that function in our code and use it there, we just pass in the URL and call it from there. But it is one that is locked down. I can point at this on the machine learning and data analytics. I couldn't even point at it. If I go in here and switch to student view. So this is the one, the Learner Lab. It's often used in the website development class. Just has some basic storage, just the basic getting started one. It didn't give an error message until I actually tried to run the function. On data analytics and machine learning, the ones that I signed you all up for, it gave an error message as soon as I tried to go to click the link for Lambda functions. It's like, no, you don't have access. But at least this one has some a couple things I can point at when it starts out, even though we can't get as far as making one. But
Hey, Chris, can you say that again? You said one single function you can run. You said in the how did you define it again? You said it's I'm sorry.
you might need to disconnect one of your machines.
Okay, I'll turn this one off.
That's fine. You can't mute, but the mute button doesn't work for that. You have to actually shut it off. But I think if I understood your question, we call it from the URL. So an address.
All right, you said one single function you can run. Say that again.
From the URL.
Okay.
From the web address. Just like we did with the API. We just create a URL that in the our class, we were starting off, we were putting it in the browser, but that's not where we would actually put it. Yeah, right. We call that we put that URL in our code so we can do something with that data instead of see it in the browser window, because it's usually not even formatted there. But it's just out on the cloud somewhere, so we can call it that way. We'll go in AWS, which we don't quite have permission to do this, but under compute, if you scroll down, there's this Lambda, which I believe Linode also calls it Lambda, but Azure and Google Cloud both call it cloud functions. Yeah. When you go in here, there's an option to create a function. Pretty straightforward. You can make one from scratch, start with a pre-made one, or this probably looks familiar from a couple weeks ago. We can set it up as a container. So we could just run this is how you would also run your Dockerized stuff. If you Dockerize it, you put that Docker container in AWS and then you run it from a cloud function. I'll say that. There's lots of different cloud providers. We call them different things. Lambda function, cloud function, whichever one you're on, it might have a different name. Let me see if Blueprint works. I tried to do one from scratch. So we create one from scratch. We'd write a Python function, and then it gives us a URL that we would ask for to run that function. Copy and paste that wherever we need to call that function from. Greetings function. Let's see if this will let me do this time. Create a new row with basic Lambda permissions. I'll try that. So that one's showing it in JavaScript. I guess I'll go over here so I can do one in Python. Say hi, 1, 2, 3, 4, 5. Maybe we'll allow that name. Create a new role. No, still saying I don't have permission. They don't like to do it on the free account. That's one of the ones that people are taking advantage of because it's kind of, it's not the cheapest functionality. So people with running businesses, that's the one of the ones they did a lot of on the education accounts. And Amazon started locking down the education accounts. Let's see if this other one works. But you can come in here and just write a Python function. They'll generate a URL for you. I guess that shows up on the next screen. Just click that and it will automatically generate the let's see if I can do this from none. Create function. No, it's still giving the message. Yeah, they have it locked here. Oh, maybe not. Say hi, 1, 2, 3, 4, 5. So none. Create. No, it's blocked. That's why I thought. But another place to write Python code, just in small snippets, and something you will probably see a lot of moving forward in the future, is starting to show up over the last year and a half a lot more. Instead of writing a big, huge piece of software for the company, we go in and write 2 or 3 functions, stick them on the cloud, and then we don't need to spend 6 months writing a massive piece of software. Okay, with 50 programmers working on it, we can just add that one function that they need into the existing software that way. So something you all will definitely see moving forward. So you might want to do some research on that. AWS Lambda functions. Just start there. All the cloud providers have it, but AWS actually hires writers to write the documentation. They don't just have the programmers write the documentation. So there's like experts in the English language writing the instructions and stuff, which is really nice. So even if you're going to do it somewhere else, sometimes it doesn't hurt to look at the AWS documentation just because they hire actual writers, professional technical writers, instead of, oh, I should end that. Yeah, we don't really have permission. I just wanted to point at it. But instead of having the programmers write it, which if anybody's ever had to dig through like Google documentation, you may have seen the downside of that. The people who are really, really good at writing programs are not really, really good at writing paragraphs in English. And the documentation is hard to follow and make sense of. But that's something to look at. Oh, documentation, that's an important thing. So let's look at something about documentation. When Spider starts. I guess I could have started that before class, but won't take too long. There we go. So there's a new thing here. I'm just going to write a couple functions in a simple class. Some stuff we've seen before. Maybe this is our software or maybe just part of it. I'll do a person class, that generic data I always do. Define init. Self, name, age, town. Self dot name equals name. Self dot age equals age. Self dot town equals town. And that's probably good enough for this class, for what we're going to talk about today. Maybe a couple functions. Define, I don't know, a void function with no arguments passed in. Print hello world. Oh, I should make at least one function here. Define has moved. And then this will say return an F string that says self.name used to live in self.town. We're not going to do anything with this data. I want the function, not whatever the function does. So I'm just quickly making up some functions in classes to use as an example here. In part a bad example because the thing I want to get to would probably be done first, not last, or at least along the way. Maybe a couple more functions. So define double x, take in a parameter, return 2 times x, or let's do x plus x. Define adding, take in a couple parameters, return x plus y. That's probably good enough for our example here. So these have to use our imagination a little bit here. But let's say these are some programs that we've already written and put together. And all right, our software is done. We're ready to get out in the world. But we need to tell other programmers how to do it. Okay, yeah, maybe it's not a software. Maybe we just made a module that we expect other programmers are going to want to import. They're going to want to install it on their Python environment and use it on all kinds of projects. Tons of useful things, more useful than what is actually on the screen, but hopefully you can use your imagination there. Right? We finished our project, but we also need to tell people how to use it. And y'all have been there before, right? Going and looking up the documentation, tutorials. We make tutorials, but tutorials usually only show the basic beginning steps. We need that user manual, the documentation that always stays up to date. Tutorials also go out of date. So when we go and put that in, and this is the reason why I haven't made comments. I don't use comments. I don't use many of the comments that don't do anything. Right, like a comment here that says what this function does. prints out the standard test, standard configuration test. So we can print strings to the world. We know everything. If we can print a string to the output, we know everything's configured correctly. So that's a nice quick test that we run all the time. And put a comment in there. You may have seen that in some of your other classes and might have noticed that I don't use those. And I don't say anything if you turn in code that has no comments whatsoever. Because I don't use those. They don't do anything. There's no point in writing something that doesn't do anything is the way I feel about it. Because what is a comment? Hey, this Python script is a text file. And a comment, well, when the computer parses through this, in particular, when the Python interpreter parses through this, it ignores comments and then runs the Python code, right? But there is absolutely nothing that stops us from doing the other way. It's absolutely nothing that stops us from ignoring the Python code and doing something else in the same text file. So that's the sort of comments I like, which would be like documentation generators. So the one I'm going to recommend, I actually put it in it was copied and pasted way back in module 1 from last year, because I made a big deal about it last spring when I taught the class. I've opened up my terminal, come over here, pip install pdoc3. Make sure you do pdoc3. pdoc1 will install, but pdoc1 was a long time ago. Then there was pdoc2, and pdoc2 never got finished. I don't know the details, but a whole bunch of people worked on pdoc3, so it always made me kind of wonder if somebody passed away with an unfinished project and all his friends finished it up as a homage to him. But pdoc2 will install, because they did publish it and everything, even unfinished. I don't know the story behind it, but you want pdoc3. So you run that install, pip install pdoc3. I already have it on here. This is one that I like. I actually really like something called Doxygen. But recently the school is blocking that for me. Doxygen. So this is actually a documentation generator for the thing. I don't know why it says it's not private. Yeah, the school started blocking that for some reason, and I don't know why. But that's the most popular one to use with C++. And I really need to click this button to bypass it. Oh, wait. Oh, usually the button, report incorrect block. I need to click that and have them bring that back up. This is the one for C++. We can define new codes, but most our languages are in there. It knows Python. It knows Python. Obviously, C++. It'll recognize Java docs. It'll recognize just about every language we have, or we can redefine patterns in it. So it's the one we have full absolute control over. But this will still work. So instead of those comments that do nothing, well, there's different ways. With Doxygen, you put special comments. In Python, we do like 2 comment symbols, then 1 on the next line. And then that's a special character, even the line break's part of the special character that sends it to the thing. Now, when I just installed, uses doc strings. So under class person, we'd start a doc string, the 3 quotes. And why didn't I do that? Maybe I have to do it on the methods. Let me do this one first. There we go. At least I did it down there. Notice Spider popped up this message, generate doc string. So I'm gonna go ahead and do this. Return. Okay, so this one is using NumPy notation, I think. I should check before I do that. Generate doc string. Yes. So this is using NumPy notation. That's one of the more common ones to use here. There's several different ones. I use Google notation a little bit more, but notice we have some special things set up. So there's this empty little spot here where we're ready to type in. Then this section says returns, and it says returns none. We just have a print statement here. A print's not a return, that's an output. So there's nothing other software can use after a print statement. And then the space up here is for a description. A method to call the standard configuration check. So these are the sort of comments that I like to go with. It adds a lot of clutter into class examples. That's why we haven't talked about it. And why last spring when I taught this, I had people do that every week. But this spring, I haven't mentioned it at all. I was like, well, I can just show you this at the end. So from that doc string, some information there. Or this next one has something different. This one takes in a parameter and then returns something at the end. So we have both of those sections. We have a parameters section and a return section, and that blank line to give a general description. A method to, I'm going to call it function here because there is a class. So I'll just kind of go with that sort of distinction, even though that's not technically right to call it a function. A function that doubles the value of, or that finds twice as much as any value passed in. So I guess the name of that function kind of told us all that, but for the point of it, again, use your imagination like we have something interesting going on here. But I just needed an example, a generic function. And we put this doc string, the very first line in the function, that's how Python recognizes that the doc string goes with that function. It says, then under parameters, X is a type. So probably better be type numeric. Int and float are both childs of numeric. We saw polymorphism earlier, right? If we need an integer, we can't use a floating point number. If we need a floating point number, we could use an integer. But if we don't know whether we have an integer or floating point number, they are both children of numeric. So they still count as that data type too. So polymorphism there, and then a description of it. The number we want to find twice as much as. Adding a little bit extra so we can recognize it. And then returns, we can figure out what the type of return was. Because it's only parameters in that return, and it's a plus sign with it, so it's concatenation. If I would have used multiply, or divide, or modulus would only return an integer. Integer division would only return integer, so it would recognize integer. But multiply, exponent, some of our other operations, it would know it was numeric. We'll see that when we get to the string one in a moment. I'll just make the type numeric, which I believe Python spells with a lowercase n. And description is twice as much as the number that was passed in. So notice we still have all those comments and stuff. And I'll go ahead and run the first version now. Let me go save this somewhere. Documents and delete. I'll make a new folder. I'll call it documenting. And this is my module.py. So again, we kind of have to pretend like we have something interesting going on in our module. But we just need we have some functions. And we need to create documentation because we think other people are going to use this. So now with pdoc3 installed, and make sure it's a 3 because they grew from the same thing. So pdoc1 and pdoc2 will also use the same instructions that we go type in. But we need the latter version. So when we go into this function, that folder. So there's the module we want to document. I'm going to run the instruction pdoc -- HTML. So I want the HTML output, and I want it for my module.py. Didn't take it long. And if I list out the contents of the folder, notice we have a new thing there, and we have PyCache. Has everybody looked at that folder at least once this semester yet? Have you noticed that that folder shows up automatically? If we go in here, we can see the type is compiled Python. So when we import stuff, it compiles and runs faster, which we also get that in notebooks. Because if we type it in cell 1 and then use it in cell 3, it has to compile getting between cell 1 and cell 3. But if you type everything in cell 1, you don't get that effect. So make sure you do small bits in notebooks. I have noticed that on a couple of assignments. People will put basically the whole assignment in one cell, and you're not getting the advantage of using notebooks when you do that. So in that HTML folder, there's this my module index, and you see we got all of that already. Well, at the very least, it's already recognized all of our classes, even though we haven't documented those, right? We haven't added any comments except for, I think, these two. Only 2 of those 3 have comments so far. If I go over to say hi, we get that description and how it returns. And it's referring to a particular style sheet, so we can customize the style sheet a little bit more. In general, does that style sheet look familiar? If that's the generic style sheet that's ready to be customized, have you seen documentation that looks like a customized version of that style sheet? By this point in the semester, I'm hoping the answer is yes, because it's a very common one. Oh, look at all that. So I knew that. Then there's the stuff about our function. So method to return that description we put in, it returns none. And on double, that description tells us what parameter we need for it and tells us what is being returned. That's what we need in order to use that in our code, right? You'll have seen documentation there. Hopefully you've used things like that in documentation. The general description.
Yeah, I've used it from other people's code. I've never written it in any kind of depth like that. Didn't know there was a way to do that.
Yeah, we don't go write a web page. It comes from comments in our code. And pretty much every language has this. So you want to use documentation generators. Some of y'all may have been curious why I haven't mentioned comments all semester, because I don't care much for comments that don't do anything. I don't put the comments that don't do anything in my code because the nature of a comment is the Python interpreter will ignore this code and run the Python instructions, but it's still just a text file. And we're programmers. We tell the machine what to do. So there's nothing that stops us from ignoring the Python code and only looking at the comments. And then we can take care of both of them in our documentation. Oh, there's that part I highlighted at the top. Notice Spider automatically sets you up to do that. So and if you want to use other ones, Sphinx. I think spelled with no, I was going to correct it. Oh, I forgot an H. I think it's spelled with a B. Maybe it is an I. every once in a while they spell, okay, yes. Sphinx is another one you would have definitely seen the documentation for at one point. They kind of changed theirs. Or something to the document. So Sphinx is, I don't know why they turned theirs white, because that's not the Sphinx one. It's very similar, but normally it has like yellow and light blue, like yellow background on the code and light blue. Pi Auto GUI has it. That's one I can look at. I knew I wouldn't have to think very long before I realized at least one that had the Pi Auto GUI. So Pi Auto GUI used Sphinx. So this is Sphinx. If you want that style sheet, you use Sphinx, and it also takes in the doc strings, both Google and NumPy notation. So it would, the same thing we're running through docs, PDoc. There's lots and lots of them out there. There's even more if you want to start searching through them. Documentation generator, Python. The PyDoc, notice that there's something called PyDoc on the official Python documentation page. It's a little harder to use. But if you ever add something that is that the official language is going to pick up some of your code, you have to go back and write it for PyDoc. Most of the other ones, documentation tools, this probably has a list. Oh, there we go. So even though they have that official one, they automatically put one on here. PDoc free. Autodoc is kind of not bad. Doxygen knows about all of our languages. That's the one. It started as C++, but just like C++ stretched out everywhere in all the languages we have today, the official documentation generator for C++ also recognizes all those languages, and we can create new patterns for it to pick up on. So if it doesn't know a language, we can add it. That's the one I like to go with, but I really dislike their style sheet. So I can pull one up on GitHub. We go to the one of our repositories down here. Yeah. So also this is where I usually use the Google Pages, is I'll put the documentation for something right there. So Doxygen gives us this style sheet, which I just don't like at all. So what I usually do is redo that. Oh, I didn't do that. I go back to GitHub, because I also use Doxygen on something down here. This one. So this takes a couple of popular game engines in Python and put them on a GUI. These GUIs are easier to work with sometimes. We use Doxygen notation here, which I guess this would have it. So it just starts with 2 comment lines, and then we comment each line and add I guess it looks like an annotation for the keyword. So like at parameters, at returns, and all of that stuff. And then that generates that one with the style sheet we just saw, or I can point to docs. But it always generates it with the same name. So what I did is I went in, there's actually 2 of them. There's one on the search bar, and then there's one at the top level. Went in the CSS file, and I just started making changes to that over the course of a dozen projects or so. Because it's a lot to do at once, but as you do it slowly over several projects, just track down what the HTML elements are called and give them a different style. Anybody that's had the 153 class should hopefully know what I'm talking about there. And I think there's a link for this somewhere. There we go. Yeah, that was just to put a GUI. So I turned that other style sheet into something close, use purely CSS to turn it solely into something like this. This Doxygen also has a search bar, which is kind of nice to search the documentation. But that's kind of stepping aside for the general point of search some of these. PDOC is really, really easy, so I'm going to recommend using that one to start off with. Come back over to Spider. Probably expand this a little bit. CS, for instance. Add a description here. Add summary. It might say add summary. I think that's a keyword that's used elsewhere. It might pick up. I'll just have to see if that works. An example of a module to cover documentation generators for an in-class example for a Python programming class. And it's making a web page. Since you know these are going to end up on a web page, you can put tags in there. Go ahead and put like bold tags and stuff like that right in those strings, and then it'll just generate the web page and throw that string on there like it was planning on, and it'll include your HTML tags, and the browser will know what to do with those. An important one when you start customizing the style sheets. Maybe I need. I'll just put it here. I'll give the person class a description. A data class to handle some example data. Nothing too fancy there, just to include the description, but then because here your Python IDE should offer to generate a doc string. If you start typing a doc string on the first line of the function, you should get something like that. And it's going to bring all these up. Name needs to be a string. Description, the person's name. I know these are all very obvious, but if we use our imagination, we can picture doing the person's age. Let me add a bold tag on that, just to show that point I was just talking about. You probably want to put that on something like the returns or something, or maybe the type would have been a better place to put the bold tag. Maybe italics. Italicize that this one's a string, and where the person lives. So you can see, like comments, you would do this along the way. A method to print an alternative string if the town data is no longer accurate. And notice this time it did figure out what it returns. It knows it's a string, and I'll just add it to a generic statement. For your actual code, it would be something obviously that applies to what you're doing. I'm coming back and make an adjustment to that in a second, but one more down here. Notice we have a couple parameters of numeric type, because float and integer are both childs of numeric. So that would be polymorphic to both of them. The first number to be added. The second number to include in the sum. And return is numeric. The summation of the two numbers passed in. So our example is extra trivial, but the point of it was the general stuff here, and description here. A function to add a couple numbers together. So even doing it afterwards, it's not long, but it's like your comments. You would do that along the way as you write your code. And then at the end, your documentation's ready to go because we just run over to pop over here and well, we just look, there's other ones. Make sure you do PDoc 3, not PDoc 1 or 2. Once you have PDoc 3 installed, run that instruction, HTML, and obviously dash HTML isn't the only option for it. I'm just gonna put a dot in this time. Normally we would do stuff like that. Dot to check the whole folder. There's only one file in there, right? I made 2 pages. So check the whole folder, it made 2 pages, but we only have 1 Python file. Let's go see what our pages look like. So index and my module. So notice that when we said use the whole folder, it assumed that, I guess it assumed we're just doing the first run and there's going to be more later where there's going to be more modules in that namespace. The modules are also called namespaces. If you've seen that somewhere else, it assumes we're going to make more than 1 namespace in our project. So to set that up on the home page, then when we go in there, here's all of this stuff. Oh, we did print that summary in that. So we can modify that a little bit. As we look at these functions, as we get that description and return type, it spells all that out. Some of the other documentation generators require even less than that for us to put in. Which one did I add that on? Oh, under classes. And these are all links. So you can click over here and jump right to any one of the functions or jump to our person class. So a data class to handle the example site. So that first description showed up here. You can write a big long description, include images and stuff, just using the HTML image tag if you want to put a picture there. There's probably a nice formal way to do it. I always just use the HTML image tag and it works because we know it's going to open with the browser before long. We get all that stuff. There's where that bold one went in. And then recognize this one though. So we missed the italics tags. They got the bold tags, so. That's strange. I don't know why it missed that tag, but sometimes it will miss them. So obviously it takes, I guess you call it debugging, just like your program. So we run through all that, we see all that information, and it tells us what the parameters are, what it returns. Notice that it completely ignored the self parameter. You see here requires the self parameter, but the parameter list is empty. So it recognizes those standards and stuff. And then we have all of our documentation in one place. We write a big doc string up at the top, giving your whole description of everything. The one I wanted to change is let's move this doc string out front. So we're going to move that out front of that class instead of inside of it. Run that same instruction again. Oh. And maybe I don't like that name. So PDoc --HTML -O for output. I'm gonna call it docs instead of that big name it gave it. And then the dot. So it created that with the folder docs. Okay, I don't know why I did. I guess I must have changed something there. If we jump down to the person class, notice that with that doc string outside of there, it no longer shows up as our description. has moved didn't get documented either. Right. I saved those changes, didn't I? Save the changes. Let me not do the output folder. Remove item docs-r. Oh, did I look in the wrong folder? That's probably what I did. I probably looked in the wrong folder. I didn't realize that HTML folder was still there. So we'll try that again. So pdoc, want to output HTML, put it in a folder called docs, and look at the whole thing. Okay, there we go. So it created 2 files, which I think is what it said last time. And I just apparently looked in the wrong folder. If I go in docs, notice it still created a folder called document string. So instead of using that output command, if I'm using pdoc, I usually just rename the folder. That's a lot easier. We open up the index, we saw all that, get that document. Notice the app summary showed up. So it did give us a couple lines there. So on your first one, take note of how much room you have on that first line. It will pull up to the first line break for enough characters to fill 2 lines. So in this case, you might want to find a nice little amount that fits on that whole thing, because then if there's a whole bunch of namespaces or modules, as we call them in Python, we can go into any particular one. We'll get that description there. Okay, yeah. So now that string's outside, notice right off the bat on the class itself, it gave us that string. It gave us the documentation for the constructor. So in the class, this string was moved outside. So then when it pulled the description for it, let me move it back in here so we can see the difference. Copy that, paste that down here. Save that. Then come over here, pdoc --html. My module.py. So it only does the one file, another folder, and I can open both of them. So when it's inside, we get that description, and then it falls into what's in the constructor. But when that doc string was outside of the class, so before it with no indentation, if I scroll slowly, you'll notice that it did not show up anywhere on this page. So make sure your doc strings go inside of the thing you're documenting. And can fill that up, add in lots of things. So I guess in general, I tend to not put this doc string and just use the description down here instead. Because in Python, we only have one constructor, so we don't have to specify anything about those or anything. I'm going to move that down there. Figure that out. But it didn't recognize the annotation, so I'm just going to make that bold. Let's see if the italics word keeps here. Probably here. I/I, and then this one would be bold again because that's a label. Save that and go clear a couple of those out. Index. So the bold tag looks like it worked there. So the italic tags worked there, which is kind of something you want to watch for. Some places the HTML tags will work, and other places they will fall short. Best way to learn where those are or are not is to just kind of play around with them. But really, really easy to make the websites that have the documentation for your projects. Definitely something you're going to want to keep in mind with software development. And do some searches for them. There's lots of them out there. PDoc is one of the easier ones to use. Most all the other ones would require is to do a whole lot of stuff here in the terminal. We have to write very special comments, and then we have to do a whole bunch of stuff in the terminal to generate the web page. PDoc 3 is really, really, really easy. PDoc 1 is hard to use. That's why I didn't use that. PDoc 2 was unfinished, but I don't know the story. For some reason, people wanted to finish that work. So the little bits that I've seen when looking at it made me think somebody might have passed away and his friends wanted to finish it. That's my impression of it. But PDoc 3 is what PDoc 2 was trying to do to make it super easy, where we need like PDoc --HTML dot, and then we get that whole website, not just a web page. So if we have 50 modules in our project, we'll get the website for all documenting all 50 modules we created in that project. So that would be my recommendation to start into those. And most of the other ones for Python do take one of the standard notations, Google notation or NumPy notation. Google notation, docstring. And NumPy notation, docstring. Well, they spelled theirs out a lot. Maybe you can just find a quick example. Google gave a really lousy example, so Google saw Python docstrings. Here. Yeah, so it's written a little bit different. It would look something like this. So we'd have args instead of parameters. We still have the return. We have a couple more line breaks. We put things in one line instead of having line breaks in them. There's the NumPy notation. That's what this has on it. I guess I could have pulled yeah. Sphinx accepts both of them, so they have, it looks like Sphinx put together something for us. This one's a little harder to use, but that style sheet probably looks familiar to y'all by this point in the semester, right? So Sphinx is the one you want to work up to, but PDoc is a lot easier to get started with and takes the same notation. But we haven't done any notes, like side notes beyond the description, include example code and all sorts of stuff. But there's, let me go back to that. Yeah, you can compare them side by side for the really good one. PDoc accepts that same notation and see, it'll know what to do with everything in either one of those docstrings. It looks like when we click Spider, or in Spider, if we click that generate docstring button, we get NumPy notation. So you get this one, and you can see there's more missing parts that we haven't filled in. Right? We haven't done args and quargs in ours. Sharp parameters. It still recognizes some of that stuff. The return type, long description on it. Raises, yeah, I guess we didn't really put any exception handling in there. But there's examples. It's definitely something you will want to look into. And that brings us up to 7:15. Anybody have any questions about that? So that's a few random things. My cereal was at the top of my notes. I forgot to build or I ran out of time to get that device built or a device built so we could do a quick test. I will try to get something made by Wednesday. But we kind of saw the general idea of that. When you need that, you look it up. So the main thing here is remember that there is a library called Pi Serial. You do pip install Pi Serial, and then you can capture any data coming down the USB port or the Wi-Fi signal or the Ethernet cord or anything else that comes into your computer from serial communication. Yeah, just remember that that library exists in case you ever need it. Is the main thing here. We'll try to look at an example of that later. Again, the AWS Lambda functions give us the ability, something almost akin to the APIs we were writing, where a URL would send us back a data set. We only looked at that in the browser because that was quick and easy, but we did also see how to pass a URL, get the results of a URL directly to a Python script. And that's more the typical thing what we would do with an API. Y'all remember that? The request module, we pass in a URL and it sends back whatever's there. So if we pass in a URL that belongs to an API, we get the data back right to our program. We were short on time, so we didn't quite see the full picture there. Might be able to quickly fit in the full picture of that on Wednesday. Have some more odds and ends, but I wanted to keep class time short tonight, or lecture time short. Our class time still goes to 9:50, right? So until 9:50, I'm going to be sitting in my office waiting for questions to come my way. But at this point in the semester, y'all probably have some work you could do, right? Finishing up things. And I'll remind you again on Wednesday and probably send out an email on Saturday. But just remember the semester or the 8-week term ends this coming Sunday at 11:59 p.m. So make sure you get all the work to me before 11:59 p.m. on Sunday. And on Wednesday, I have some more odds and ends, but expect it to be a lecture that would go up to about our normal break time. It might go a little bit longer because I want to look at the OS module and maybe some stuff from the SIS module and possibly use those APIs we wrote earlier in the semester to, instead of looking at them in a browser, we'll actually use the request module to bring them directly into a Python code so we can do things with them, other than seeing them in a browser, because that's kind of useless thing to do with data, right? We need to put it somewhere useful. Does anybody have any questions about stuff this evening? That leaves a big chunk of time. Please use our time productively. I teach more than just this class, so if you have something more pressing in another class, feel free to send that my way. For those who haven't seen the list, like over in the tutoring center, I'm actually a math person, but the list over in the tutoring center is got math, physics, IT, hardware and software side, writing. Depending on the semester, sometimes I've tutored CAD stuff before. It's a long list of subjects I can help with. And from now until our normal schedule block ends at 9:50, that's what I'm going to be sitting around waiting for questions. If you have any, send them my way. I'm always happy to help. Obviously, the Python questions have to take priority right now, but I can answer questions for things other than just this class if you have other pressing work to do. Otherwise, you all have a great evening, and I will see you on Wednesday with some more odds and ends that I believe will be useful for you.
Thanks, Chris. Bye, guys.